So tonight we have a guest speaker that we're very honored to have. I'm proud to say, I don't know what his focus is when he first got his professional degree, but chemical engineers are a very special type of degree. Not easy at all. And I know what it takes. I'm married to one, so I have a great respect for the fact that he has that kind of background and training. So I'd like for you to have a big welcome for David Tomasko, Dr. David Tomasko.
I hate to say this, I'm not a chemical engineer, well, but there's another David Tomasko who is one, yeah. Most of my family are like coal miners and steel workers, but there's a chemical engineer out there and a marine biologist, which is kind of strange. There's a lot of marine biologists in Western PA.
That's still chemical.
Can we do the display screen?
If I do that, I'm going to see if I'll get these controls.
Oh, yeah, okay. No worries. You guys can see this, all right? Right?
Not really.
Not really? Oh.
Okay.
Well, we're stuck between a rock and a hard place.
As long as I don't have to do controls, I guess I can do it.
Yeah. Hey, can I give it a shot for a second? Sure. And this may not work.
Yeah, you got it.
What year is it?
Oh, dear.
All right, there we go. And then I think you can just, yeah. That'll work all right?
It works for me. I don't know if it's any better.
Oh, yeah.
Oh, yeah, it's huge. That's great.
Now stay on close, right?
Oh, that's wonderful. No, see, that's one for Zoom. Okay.
Yeah, but it's working for them.
That's fine.
Cool. All right, so
first thing that they talked about was
all right, so I'm going to talk about Midnight Pass. We're going to talk about Little Sarasota Bay, but we're not going to just talk about that because there's more to the health of the bay than just that. So next, please.
Yeah, I'm going to mute everybody. Everybody on Zoom, please go on mute. Right.
So when we talk about the bay, the first thing we don't talk about chemistry right away. We don't talk about we talk about the quality of life. So this is what your neighbors do. This is what I do. The number goal for the Sarasota Bay Estuary Program is to improve water clarity as good as it should be for that particular location, because people go out, throw out their anchor, and they stand around in waist deep water, and they want to be able to look down and see their feet. And they don't want to have rafts of macroalgae wrapped around themselves, their family, and that sort of thing. So quality of life is a big part of it. Next, please. It's also important for our economy. There's 20,000 jobs that are associated with bay-related activities. The commercial fishing village of Cortez, there's not a lot of commercial fishing villages left in Florida. We have one right up there on the north part of the bay. Recreational fishing guides and the waiters and waitresses and bartenders and restaurant owners for waterfront properties, and also people who rent you jet skis. And there's also a property value uplift associated with proximity to the bay. That's probably about $4 billion. So your ability to pay for schools and police and fire is a function of people wanting to live next to the water. But think about what it was like in 2018. And you know, how much did you want to be on the water in 2018? And also, we know that during a red tide, from a really neat work project that was done by the University of Rhode Island researchers, property values are depressed 20 to 30% up to mile inland in coastal properties experiencing a red tide. So red tides depress property values. People pay more to live on clean water than they do on dirty water. Next, please. And there's a lot of habitats that depend upon good water quality. So for example, we want to make sure everyone understands the things that we talk about, because not everyone's from Florida, and not everyone who's from Florida spends a lot of time underwater like I do. So this is an underwater photo that shows seagrass meadows and mangroves, and hopefully you can see the school of fish there. So about 70% of the shellfish and finfish that we like to eat or like to catch depend upon things like seagrass meadows. And so this plant right here is needing water to be clear because it needs sunlight to penetrate through it. So the water clarity is really important. Next, please. And so I show this slide because it's the cutest picture in the world, right? These are people bottle feeding baby manatees. But the reason why they're bottle feeding baby manatees is because their moms starved to death, drowned because there wasn't enough food, because the Indian River Lagoon is in a state of near total collapse. Water quality is bad, the water clarity is reduced, the seagrass biomass in the Indian River Lagoon has dropped 95%, And we have lost statewide 20% of our manatee population. Over on the East Coast in the last 2.5 years. On the East Coast, it might be 30, 40%. We don't want that to happen in Sarasota Bay. So for it not to happen, we have to do the following. So managing Sarasota Bay means managing nitrogen. If you want your lawn to look nice and green, add nitrogen. If you want your bay to look green, add nitrogen. If you want your tree to grow fast, add nitrogen. If you want algae in the water to grow fast, add nitrogen. But you don't want that. So it's really about managing nitrogen. It's not adding it, it's like controlling it, which means find out where it's coming from and how much you have to reduce it. Click on it again, please. So yeah, so the red represents the only thing you have to measure. So state of Florida gives a report card about how healthy systems are, Biscayne Bay, Apalachicola Bay, et cetera. And it's based only on going out and dipping your hand into the water and taking a water sample. But there's a lot more to the health of the bay than that. And so we actually, and our partners, measure the water quality every month. Sarasota County, Manatee County pay for that. The seagrass maps are mapped every 2 years by the Water Management District. The fish populations are monitored. They've been monitored for about a decade, I think more than a decade, at 200 spots throughout Sarasota Bay. And so all these things, and we actually use volunteers. If you want to volunteer with us, we train volunteers to go out there, snorkel on the ground, and quantify how much algae is in there, the big tumbleweed type of algae. So all of this stuff is out there, and all of it is important. Next, please. So with that, we come up with a report card. The report card has 4 elements. 2 things are in the water: nitrogen concentration in the water, chlorophyll A, which is a measure of how green the water is, which is a measure of how much algae is in the water, and then the amount of seagrass meadows, and then the amount of big clumps of macroalgae that doesn't fit in a water bottle, but is easily blown up against the shoreline. So all 4 of those things are in there. And we take our results and we color code them. What matters is not the number. What matters is the pattern, the spatial pattern, and the pattern over time. Because my audience is not, given a presentation like this, my audience is not to PhD marine scientists. That's like preaching to the choir. We want to expand the congregation. We want more people. That was a great place to use that term. So we want to get more people to understand what it is that we're talking about and why we need to do some really expensive things. So next, please. So we have a report card that includes 4 metrics. It's based on a reference period. That reference period is 2006 to 2012. We don't know what Sarasota Bay was like 100 years ago. We don't know what it was like 50 years ago. We have water quality data that goes back 30 years, but we don't have like the algae, which is really important as well. But we know that 2006 to 2012, we had lower nitrogen, we had less algae in the water, we had less macroalgae, and we had a 28% increase in seagrass. That is good, and that is an attainable goal. So our report card is, how are you compared to that time when this bay was healthier? So next, this is our report card. Remember, blues and greens represent good. Blue is like offshore, Gulf of Mexico, good conditions. Yellow is caution, like something's going wrong, take care of, watch what you're doing. And red means stop, something is, you need to fix this or else it's going to become, bad. And what you can see is 2006, 2012, it was blues and greens across the bay because this was a healthier bay across the bay 10, 15 years ago. It wasn't that long ago when this was a healthy bay. Tomasko Bay, which is up in that north corner, around like between Bradenton and Anna Maria Island, that still is a healthy system. And so there's lessons we can learn about how did Tomasko Bay stay healthy. The upper part of the bay was doing pretty good until 2018 when it shifts into yellow. That was the red tide. That was the strongest red tide we've had here in probably about 20 years. And red tide, if it's more than 100,000 cells per liter, is strong enough to start killing fish. This was 14 million. So it was 140 times stronger. So it killed a lot of fish, made its own fertilizer. It lasted a long time. We lost 20% of bay seagrass in one summer because it was so very dark. So the lower bay shifts to yellow back in 2013. It rained a lot in 2013, but what really happened is that was the beginning of a 5-year period where we had more than 750 million gallons of wastewater overflows from Sarasota County's Bee Ridge wastewater treatment plant. 750 million gallons. That is more than 3 times as big as what came in Piney Point. And so that set us back for years, if not decades. That got rid of about 20 years of successful, improvements in water quality. That's not happening anymore. Sarasota County is in the middle of expending more than $200 million to upgrade that wastewater treatment plant, and it'll be state of the art, as good as the city of Sarasota, which is probably one of the best ones in the state of Florida. And so that's not going to happen. So you can see that we start to get better in around 2021, but then 2022, we have Hurricane Ian came through, and Ian was more powerful impact in the lower part of the bay than the upper part of the bay. So Palm Sol Bay doesn't have a problem, but the lower part of the bay, which was blues and greens, 2021, we were like bragging about how great it was. Look at this recovery. Look how the water quality has gotten better. And then 2022 came about, but you're always going to have hurricanes, and hurricanes will set you back whether people live in the watershed or not. So next, please. So the big difference between that healthier time period and the latter time period is the nitrogen load. And the nitrogen load is about 20% higher. Why? Because more people moved here, more impervious area, more grass clippings, more dog poop, more stormwater runoff, more wastewater, more overflows of wastewater treatment plants. And so if we want to get back to that healthier condition, we have a goal of a 20% load reduction. Or another way to look at it is 12 tons of dissolved inorganic nitrogen. That's not going to be easy, but it's not going to be impossible. So next one, please. Can we get 12 tons? And the answer is yes, we can get 12 tons because there's more than 12 tons of what we call controllable nutrient loads. Reclaimed water. Do you guys have reclaimed water in Siesta Key?
No.
Okay, good. Because reclaimed water from the Siesta Key, from Sarasota County's wastewater treatment plant is way too high of nitrogen, and it will just cause, more nitrogen to come through than the grass needs, and it will create a plume of nitrogen that moves out laterally into the water bodies. If you do have a lawn, please fertilize carefully, and you do not need to fertilize your lawn in the wet season. You get enough nitrogen from rainfall. Rainfall's got more nitrogen than tap water, but reclaimed water can be a great way to like irrigate, but reclaimed water from a treatment plant like the city of Sarasota is about 2 milligrams per liter. Reclaimed water from the biggest wastewater treatment plant in Sarasota County, Bee Ridge, was 18. It was 9 times higher. So that's a big difference there. But those overflows, 6 tons per year, those aren't really happening anymore. And we know they're not happening because we get money every time they have an overflow. And we don't want that money. We put it away in a bank account for restoration. We don't use it for our program or anything like that. We set it aside for restoration, and we're not getting checks anymore. And I don't want those. I don't want that money. I'd rather not have that money. So there's more than enough to do what we need to do. Next, please. Oh, that's probably me, Heather. So once we get that, we don't want to like spend all this money, get our water quality back, and then let it deteriorate again. Because what the story of Sarasota Bay is, this is really the re-restoration. Sarasota Bay Estuary Program is one of 28 estuary programs in the United States, patterned after the Chesapeake Bay program. But the oldest one, because in the 70s and 80s, Sarasota Bay was in such bad shape that locals around here asked for an EPA program to tell them what needed to be done. And we got better. This bay was healthier, then we kind of let it slip away from us. So we want to spend that money, get that system back healthy, and then we don't want to let it slip away because we have more people. But there's other things happening, which is we're going to be faced with challenges over the next 30 years that we didn't have over the last 30 years, which is the climate is changing, and you can debate it, you can believe it or not, it doesn't matter. It is changing, and we're going to show you some of the data. We don't rely upon reports, we rely upon data. We got lots of data. This is a shot of Lombo Key Village, and this is what's called blue sky flooding. Blue sky flooding because there's no rain clouds. And also you can see it's not a stormy day. It wasn't like you had a storm that like blew water over the top of the seawall. The water in that road is from Sarasota Bay coming up into the streets through the storm drain on a high tide with a full moon or a new moon, what we call spring tides. Spring tides aren't seasonal. Spring tide means a tide that springs forward, you know, when you have a full moon or a new moon. So this is the kind of thing that we're seeing. Next, please. We've got a lot of data on water levels, and water level, of course, I've lived and worked on boats for 40 years. Water level changes over the course of the day. It changes, of course, the week, month, and all that. These dots represent the average monthly sea level and over the last 20 years. And if we look at the total period of record that we have, there's a lot of variability, but there's no trend. If we look at the last 20 years, there's a lot of variability, but an underlying trend. That red line goes through that cloud of data. and it shows sea level has come up 6 inches in the last 20 years. Expected to come up another 8 to 9 inches over the next 30 years. It's not scary, it's not terrifying, but it's not zero. And what it means is that there are things that are going to happen, they're going to get worse. And I think what we're going to see more than anything else is we're going to see it's going to be harder for streets to drain runoff when it rains on the high tide. And that's what we're seeing in more and more places around the bay. Next picture, please. This is, if you want to see blue sky flooding, go out on we're going to have, I think, we're going to have a spring tide in about 3 days. So go there, look at your tide tables and go up to Bradenton, Riverview Boulevard at 22nd Street. It's the best example. Picture on the bottom, that's not a canal, that's a road. And that's happening right now. Blue sky, there's no rain, and that's not a rough day. You could paddleboard on that water right there. But that water is come up into the street. If you go there on a high tide, and this is not a king tide. King tides are a different type of tide. It's called a perennial spring tide. This is something that happens twice a month for 2 to 3 days. And you can actually see fish in the streets. They're not big fish. It's not a snook, you know, unfortunately, but they're small little fish and they are in the streets on a high tide. And that's just what happens. So that's the best example we see. And if you can see the picture on the right, see where that orange cone is? See the concentric ring around that? That is the water from the Manatee River being pulsed as it comes into the street. So imagine trying to sell that house, you know, during that, or worse, imagine buying that house on a low tide and you come back in a springtime. You're like, this is salt water. This is not rainwater. This is salt water. Next, please. This is a really neat data set. This is more than 100 years of temperature data. If you have an airport, you have a great air temperature data set. And so what this is each one of those little squares represents comparing the month of that year, January through February, all the way from 1900 to what was the average temperature for that month for the 20th century. So 1900 to the year 2000. So the average January, the average March, the average September. And if you were exactly the average, then you're a clear box. If you're cooler than average, you were kind of light blues. And then if you're really cooler, then you the darker blues. If you're warm, you're yellows looking to brown. So if you look at the first 100 years, it's kind of a mixture of yellows and blues. Look at the last 20 years. And what you see is it's hardly any blue. We are consistently warmer than we were the last century. We used to average 2 to 3 freezing temperatures per year in Sarasota. If you've lived here long enough, do you remember how you would have your sheets that you would put out on top of your vegetation to guard it against freeze? How often have you done it in the last decade?
I do the last 2 years.
Yeah.
It snowed. I remember when it snowed.
Yeah. We used to start off August days in the 60s. Not every day, but and certainly not noon, but you would start off in the morning in the 60s. We haven't had a single hour of any of the days in August of the last 20 years where it's been cooler than 70 degrees. It just doesn't get, this is what greenhouses do. Greenhouses aren't meant to make it warmer. It's meant to keep it from being as cool. And that's what's happening. Our water temperature, it appears, it used to be about 9 months a year where it was above 68 degrees Fahrenheit. Now it's 10 months. So the concern is, what if it never goes below 68 degrees? The water temperature in Gulf of Mexico is 90 degrees right now. And we're in June 1st. And it's 90, it's not 80, it's 90 degrees. So it is getting warmer. And that means a couple of things. One of the things it means is, next please, sorry, you're doing great on it. We've got a database for tropical storms and hurricanes that goes back to before the Civil War. And each of those dots represents either the number of tropical storms and hurricanes on the left-hand side, or on the right-hand side, category 3 and higher. And the red line is the 5-point moving average. So rather than complicated stats, you can just see the overall trend is increasing tropical storms the last couple of decades. But look at the graphic on the right, which shows category 3 and higher. The first half of that data set, there's an awful lot of zeros. We've always had hurricanes. We've always had strong hurricanes. But we had a lot of years in the first part of this data set where we didn't have a major hurricane. We had a hurricane, but not a category 3 or higher. And the last part is very rare where we don't have a category 3 or higher. We've had Irma, we've had Michael, we've had Ian. You know, Ian was a category 5, not when it made landfall, but Ian was a category 5 out of the Gulf of Mexico. So was Michael when it made landfall. So there's some powerful hurricanes because hurricanes are heat engines and they're taking warm and moist air and warm water and they turn it into mechanical energy. And the mechanical energy is winds and waves. So we're making more powerful hurricanes by giving them more energy for them to feed off of, basically. And one of the reasons why that's important is, other than the impact that it has on us and our neighbors, it is the impact it has on water quality. Next, please. So this is drone photo that we took of Blackburn Bay in August of 2022 on the top, and then October of 2022 on the bottom. So the August is in the wet season and beautiful. This is what we were talking about, how beautiful the bay was looking. And then look at the bottom picture, and it looked like root beer, and it didn't smell like root beer, it smelled like a compost heap. But we had problems with that we're going to talk about that are related to hurricanes, but also related to the susceptibility of Little Sarasota Bay due to the closure of Midnight Pass. So we had a problem with water quality when Ian came through. Next, please. So we sampled water quality 3 locations in each of the 3 bay segments, the lower part of the bay, 3 times. 1 week after Ian, 2 weeks after Ian, 4 weeks after Ian. We were out there like 4 days after landfall, sampling water quality. And the graphic on the left is the amount of bacteria. The red line means the never to exceed value, which means this is out in the intercoastal waterway. This is bacteria levels so high that it's unsafe for it coming into contact, like you dipping your hand in the water, that sort of thing. And it stayed that high for 2 weeks. The graphic on the right is the amount of algae in the water. And you can see that red line is our target, and it stayed elevated for 2 weeks in all parts of the bay. And Little Sarasota Bay was the highest amount of algae 2 weeks afterwards. So that is really probably a function of the long residence time of that system. Next one, please. So it did get better, but how did it get better? Because it moved all that stuff out to the Gulf of Mexico. So all the porta potties, all the overflowing wastewater treatment plants, we don't even know how much wastewater overflows we had, because so many of the reports were over 2,000 gallons. So that's like the minimum reporting unit. So over 1,000 gallons, excuse me. So it could be 10 million gallons, it could be 1 million gallons, it could be 1,100 gallons. We don't know. All we knew is it was over 1,000 gallons all over the place. Where I live in Palmetto, we had wastewater overflows that were never reported at all. And yet I've got video of them. So we don't know, but there's an awful lot of wastewater, awful lot of stormwater runoff, a lot of dog poop, a lot of grass clippings, a lot of fertilizer runoff came into the bay, and then it washed out into the Gulf of Mexico. And what we had is we triggered a red tide. And so this imagery right here is from the European space satellite called Copernicus. The warmer colors represent more phytoplankton, and in this case, it's red tide, Carenia brevis. So we see 1 week after that, we see a red tide that is probably several hundred square miles in size. Tampa Bay is about 350 square miles. The area that's yellow to orange is more than that. So I don't know, 200 to 500 square mile size red tide. And that red tide hung around our coast and moved up to the north. And 2 months later, we had that red tide that was so strong this last winter, if you remember that. Next, please. So onto the topic that we also want to talk about down here, which is Midnight Pass, Little Sarasota Bay. So the picture on the left is taken sometime in the 70s. It's basically, hovering over Casey Key, looking to the north, and you can see Casey Key to the bottom, Siesta Key to the north. And you can see the pass between the two, which connects the Gulf of Mexico to the left and Little Sarasota Bay to the right. And that island mass in there is now the Jim Noel Marine Preserve. The picture on the right was taken by a drone pilot in August of 2022. There's no pass there. But what it shows, as a marine biologist who actually put myself to grad school as being a commercial fisherman, it has an awful lot of fisheries habitat there. And that type of fisheries habitat that you can see is important consideration. So what you see is the mangroves, and you see seagrass meadows. You can see to the bottom of that bay. Little Sarasota Bay is definitely different. It's definitely got problems that need to be addressed, but it is not dead. Don't use that language. It doesn't help you make the case if you want to reestablish that tidal connection. So seagrass meadows, mangroves, those are things you have to take into account if you want to reestablish that tidal connection. Next, please. So the effect of closing that pass was studied very intensely 30 years ago. It needs to be studied again because the bay is different. It's warmer, it's deeper now than it used to be. But nonetheless, this was the most detailed study because it was a calibrated model. People actually set instrument towers up there to measure how the water moved. And then they played around with the model with different scenarios, but there was a calibrated model. And so if you want to know what did Midnight Pass's closure do to circulation in Little Sarasota Bay, you can answer that by next one, please. Click on the red boxes and you see the numbers 27 and 74. That's the amount of water exchange over 10 days. Used to have 74% water exchange after 10 days. With the pass closed is 27. So it's a 2/3 reduction in circulation with the closure of that pass. Next, please. As Little Sarasota Bay becomes poorly flushed, Roberts Bay becomes better flushed because the water still gets into Little Sarasota Bay on an incoming tide, but it comes in not just from the west, the north, and the south, but from the north and the south, predominantly from the north. The other thing that's done is, what that means is when Philippi Creek is discharging, it now gets transported into Little Sarasota Bay. So Philippi Creek affects more than Roberts Bay. Philippi Creek now comes into Little Sarasota Bay. That's probably why you had the problems for that 5-year period, because you're now susceptible to a pollutant load that you probably weren't susceptible to in the past. That's an important consideration. Next, please. So one of the other important questions is, what did the Intercoastal Waterway do to the past? And this is a complicated topic, and this is a 30-year-old model. But this model basically, you can answer that by looking at those two numbers. So when you look at the green circles, 70 and 83, that suggests that constructing the Intercoastal Waterway increased the flushing in Blackburn Bay, because Blackburn Bay is right next to Venice Inlet. And think about Venice Inlet and the ICW going through there. Venice Inlet has existed, for a long time. It used to be called Casey's Pass, but it has been really excessively modified. And the ICW, definitely affected Blackburn Bay. But next, please. Little Sarasota Bay, maybe not as much. And that's actually an important consideration, because the construction of the Intercoastal Waterway has been suggested by some as dooming that pass to failure. Intercoastal Waterway was basically finished in 1964. This pass stayed open for 20 years after the ICW was completed. So it certainly might have had an effect, but did it doom it? If it did, it took 20 years. And that actually is important, because that means, what kind of a project do I need to reestablish tidal connection? Do I have to go all the way to the ICW to get water to move enough to be stable or not? And that's an important consideration to consider. Next, please. Water quality. So if you want to reestablish a tidal connection, don't call Little Sarasota Bay dead. Don't call it a toilet that needs to be flushed. That doesn't help you. It's not accurate. It doesn't help you. Because if you're an outsider and you hear that, it sounds like you can't take care of your wastewater, can't take care of your stormwater, so you just want to flush the toilet in the Gulf of Mexico and make the next red tide worse. You're not going to get a lot of friends that way. Don't say that. It's not true. What is true is you have a water quality problem that exists, but you also are acting upon the water quality problems that you can act upon. So these dots represent the average nitrogen concentration on the left and chlorophyll concentration, how much algae is in the water on the right. And the red line here is the 2-point moving average. And what you can see is the highest nitrogen was a couple of years ago, about 2016, 2017 time period. And it was going down until Ian came through, but you were spending a lot of money on wastewater, and it is driving your nitrogen concentration lower. 20% reduction in nitrogen gave you a 50% reduction in the amount of algae. Be proud of that. Use that, because if you want to reestablish the tidal connection, you don't want to give the impression that you have a toilet that you want to flush into the Gulf of Mexico. You want to say, I dealt with my water quality issues as much as I can. Now I got to act on the other thing that is affecting it. Next, please. Also fish. You're going to have to take into account the fish habitat that's out there. There's 600 acres of seagrass in Little Sarasota Bay, and most of it is clustered right around Midnight Pass and Jim Neville Marine Preserve. And because you have that much fish, that much seagrass, you have a lot of fish. FWC samples 200 spots throughout Sarasota Bay. They've been doing it for over a decade. They sampled 30 different locations in Little Sarasota Bay. And if you take the number of fish divided by the sampling effort, it's called catch per unit effort. It's number 2 only to Tomasko Bay this year. The next year after this report, it was number 1. There are a lot of fish in Little Sarasota Bay, but they're small, because we've known for 30 years, Little Sarasota Bay is a nursery habitat. And maybe that doesn't matter to you, but it does matter to people who have to sign up on your permit. And if you only like big fish, you have to worry about where they were when they were little, because you don't have big fish if you get rid of the little fish habitat. So it's important consideration to think through as you decide how are you going to describe what you want to do to a regulated community that's going to be skeptical about this kind of thing. Next, please. However, I've spent half my career in the private sector, and I've worked on 3 tidal restoration projects. All 3 of them got their permits, 2 of them are already constructed. And the one that's most similar to this that I've worked on is a project in Puerto Rico I worked on. And so this is a picture of the San Juan Bay area. If you've ever flown into San Juan, you fly in to the airport in an area called Carolina, and you fly over this area. It looks like a Brazilian favela. That's to the right. That is the Martin Pena Canal, Pena Martin Pena. That canal used to connect San Jose Lagoon in the middle to San Juan Bay proper to the west. And that canal has filled up with garbage. And so my project was to determine the ecological benefits, water quality, and habitat of reestablishing that tidal connection. And if you look at San Jose Lagoon in the middle there, it's kind of similar to Little Sarasota Bay in the sense that it's not connected to the Atlantic Ocean. It's connected to 2 water bodies that are themselves connected to the Atlantic Ocean. So what we found in this system was that there was a problem, and all we had to do to get our permits, and we had Puerto Rico Department of Environmental Quality, EPA, Army Corps, National Marine Fisheries Service looking over our shoulder. We got the permits. All we had to do was show that we had this thing called salinity stratification and bottom water hypoxia. That's it. So what happens is in the rest of the normal parts of San Jose Lagoon, the salinity is kind of equal top to bottom. But in San Jose Lagoon, when it rains, there's not enough water movement. And so the water tends to be fresher on the top, and it traps the water below it, and there's no oxygen because it's not getting oxygen from the atmosphere, and it's kind of dark, so it's not getting any oxygen from photosynthesis, and that causes a DO crash that causes very low levels of biological productivity. That's what happened in San Jose Lagoon. That's all we needed to show to get the permits for reestablishing a tidal connection. So does that happen in Little Sarasota Bay? And the answer is, next please, it does. So this is after the storm, 1-2 weeks after the storm, the salinity stratification, the bigger the number, the more the layering, if you would, of fresh water on top of salt water. And the highest numbers in Little Sarasota Bay. And the oxygen levels are lowest in Little Sarasota Bay. The same problem that we had in San Jose Lagoon is what you have in Little Sarasota Bay. That, in fact, that the algae levels were very high 2 weeks afterwards. You've got a problem, and you can't fix that with wastewater and stormwater. You got a problem that needs the tidal restoration project. Next, please. So the issue is the estuary program is not against reestablishing tidal connection. The estuary program is not going to tell people what to do, but we're just trying to point out 15 years ago, this community spent $800,000 and didn't get close to getting a permit. You just didn't. I mean, you were basically told, withdraw before we deny it, because if we deny it, you might not get another swing at it. So if you want to go through that again, go through with the exact same design as you had 15 years ago. But if you want to be successful, maybe try a different approach. So what we're suggesting is try a different approach. And one of them is you have to have a do nothing scenario, which is it's going to be required. Army Corps, National Marine Fisheries Service, the EP, you're going to have to sign up on your permit. One of the things you're going to look at is like do nothing, which means don't do nothing, but it means what are you doing right now to improve water quality if we don't have this tidal restoration? So you highlight your stormwater, you highlight your wastewater investments, and you make yourself look good. You're not trying to flush filthy water out in the Gulf of Mexico. You're trying to address the issue that's still there. Next one. You could just basically reestablish a wild pass. And that was the plan basically 15 years ago. But are you familiar with Heron Lagoon? Heron Lagoon is the old pathway for what was Blind Pass. So look, you've had a pass that connects Little Sarasota Bay and the Gulf of Mexico, but it has moved miles up the coast. But now you got houses on the barrier island. Heron Lagoon used to be the connection between Little Sarasota Bay and the Gulf of Mexico back in the 1920s until the 1921 hurricane came through. Passes moved. Look at the history of Clam Pass in Collier County. Collier County maintains Clam Pass between Outer Clam Bay and the Gulf of Mexico. They've had to dredge it multiple times. They've had to dredge it twice in a year. So passes will move and passes will close in this area. Next one. What's gotten a lot of attention is let's just put in a hardened structure with a jetty. Let's do that, right? Venison, that kind of thing. But look at that right there. That is from the southwest looking to the northeast. That boat is coming in from the Gulf of Mexico. And what you see is Look at the beach on the north side, and look at the absence of beach on the south side. You put in something like this, and if you live on Casey Key, you might not be too happy, because the reality is sand moves north to south as a function of the sea breeze and the Coriolis effect. And so not only are people living south of a hardened jetty not going to be happy, but you're not going to have an easy time getting a permit for things that need a beach like sea turtles. This is a very difficult thing to do. So we're suggesting maybe look at a fourth scenario as well, which is a culvert. And I don't mean culvert like a pipe. I don't mean something with a pump and electricity and something a manatee gets stuck in. I mean the big kind of things. A culvert is just basically a description of a structure. It could be concrete, could be sand with concrete on part of it that allows water to move past a barrier or a barrier island. It's only 200 feet from the Gulf of Mexico and Little Sarasota Bay. It's not that hard. I've actually got a project in Old Tampa Bay I worked on that was 200 feet, but allows water to move and would still need to be maintained, but wouldn't have as many regulatory issues as some of the other things you might want to do. It's a commonly used technique in Rhode Island, in Massachusetts, Connecticut, and there's one right here in Tampa Bay and in Fort Desoto, you can see. It won an award in 2015. So just a consideration. Look at 4 different things, not just one.
How big is this culvert?
Depends how big it needs to be to allow the water to move through with it being stable. Whatever you do, you have to maintain it. There's nothing you can do that you can just put in and walk away. You're gonna have to maintain anything you do.
Now, we're talking about a closed pipe, or we're talking about an open?
Could have a top on it. I don't mean a pipe. If you look at the best probably example of it would be the one that I worked on, the last one I worked on was in Old Tampa Bay on the east side of Courtney Campbell Causeway. That was a $20 million, basically a bridge, which is a culvert with a road on top of it. Cost $20 million, which is, you know, not cheap, but it's not that expensive compared to like some of the other costs been out there. And that has a 4-lane highway on top of it. So you can establish tidal connection. It's a common thing that's done in lots of locations. It's just how you do it. But yeah, nothing that a manatee would get caught in. Something, if you make it too broad, then the velocity might go down a little bit and it could fill up. If you make it too narrow, then you might shoot out too much sand in too many locations. So it's really a matter of the engineering. Next, please. But first thing, please, whatever you do, meet with the regulators up front. Don't spend hundreds of thousands of dollars and then find out that we can't permit this. Meet with them up front, find out what are the constraints on what they can permit, what they can't permit, and come up with something. This really, you're one of the few places that has been unsuccessful for 40 years. And I saw Jim Herbert earlier, and I really apologize that it's been this way, but don't keep doing the same thing. Try a different approach and you'll probably be successful, I think. And next one, please. So cleaner bay is more resilient bay. Keep this in mind. The bay is changing. The water's getting higher. It's not scary. It's not 6 feet, but this bay will be different over the next couple of decades. It's getting warmer. We're going to be more likely to be hit by more powerful storms over the next 30 years than the last 30 years. And whatever you do, this bay being cleaner is going to be a more resilient bay for you. And last one, that's perfect. If you want to learn more about our program, go to sarasotobay.org or point your phone camera at that QR code, and that'll take you to what's called our ArcGIS version of our comprehensive management plan. And you can download the PDF and you can actually have it read to you in the accent of your choice. So,
Hey, we'll put it on our website too.
yeah, sounds good. Perfect. And that's it. That's all I had.
Questions from everybody about some of the ideas and the things he was sharing. One over there.
Gentleman in the back.
I read about when the closure originally happened back in the 80s, that there was a requirement that the homeowners relocate or attempt to relocate back, and that had failed. Why has that failed in the past, and what can be done going forward to ensure that it doesn't fail again?
I don't know why it passed, but that's a really, really important point, because they never had a permit to close the pass. They had a permit to move the pass. And honestly, a lot of people think they shouldn't have gotten a permit to do anything. They should have just like moved the house. But that's not what happened. And but that is really important, because the permit obligation was not to close it. The permit obligation was to keep it open. They tried, I think, once or twice. Jim would know better than I did, but I think they tried it once or twice, didn't stay open, and then they got let off. And I don't, people like to, demonize the folks who did that. They thought they were going to do something that was going to be a fix that would work. I'm not a coastal engineer, but that's where the engineering expertise has to come in. how can we do something that actually is not going to close up again? And that's why the idea of a culvert might make some sense. Something that actually is a physical structure that would be difficult to, close up.
The question here?
Oh, Jim.
In 1983, they had a problem with threatening their homes. So they went to get a boat permit. They got an authorization to do what they did in a single month. Without any studies, nothing at all. They started to dig and they hired Bergsteiner to do it. And after the first dig, after the second dig, they tried 5 times.
5 times.
After the second dig, we were down, one of our people was down there, and they talked to, I think it was Chico. He was one of the, he went up to the Solomon House and asked to talk to him about it. He said, this is never going to work. And the answer was, shut up and keep doing your job. And after the 5th time, they gave up and said, the heck with it. The county sued them. They settled for $15,000 apiece. Solomon paid it, and Carter negotiated it down to 5,000. So they closed it for 20 grand.
Yeah, that's that's really important. The history is really important. Maybe this was going to close by a hurricane, but it didn't. It was closed with bulldozers. Yes, I think, ma'am.
I'm curious. In one of the slides, it showed that Tomasko Bay was the healthiest.
Yeah.
Okay. I've heard people say that
The
with all of the horseback riding that they're doing there, that it was making it worse. And when I look at that, I'm like, well, maybe we should bring the horses here.
I've given a lot of presentations in Bradenton, and it always gets brought up as the horses.
No.
The horses are having an impact without a doubt. They're trampling, but like it's not really in the sense of the bay as a whole. It's just not noticeable. Horses do poop, and it appears from some people that they're trying to get the horses to poop in the water because that way they don't have to clean up after them. I don't know if that's true or not, but I've seen some people who basically said that they want the horses to poop in the water because that way they don't have to clean up after them, because they do have to clean up if they poop on the beach.
You can't make a horse poop.
I don't know, man. I can't make my dog. But I do know that, like, regardless of those issues, I just looked at bacteria data today. Tomasko Lake continues to be a pretty healthy system, and despite the fact it's got a causeway, despite the fact it's got horses, and that probably has to do with the way it developed. So if you go drive around Tomasko Bay's watershed, it's kind of more of a blue collar neighborhood. There's not an awful lot of hard stormwater infrastructure. So you don't have curbs and gutters and stormwater pipes that take all the lawn clippings from Camelon and blow it out into the bay. It's not like that. No one has lawn service. I live in Palmetto. No one's got lawn service in Palmetto. And so we don't over fertilize our lawns, and we don't have those storm drain overflows. And it's almost like LID by accident, by being cheap, by not wanting to pay for sidewalks and curbs and gutters. They actually, when it rains, it soaks into the ground. And that's probably a good way to like mimic how to develop. Yes, sir.
Hi, I live on just south of Blackburn Point Road on the water. And I saw on your chart comparing the years and different locations within those Sarasota Bay, the Blackburn Bay, you have it as green. 2022. 2022 is a terrible year.
Yeah.
On the water.
Yeah.
How does that? How do you rationalize it to be on your scorecard to be green?
Yeah.
When we couldn't even go outside for about 4 months and enjoy our outside. We had a massive fish kill.
Yeah. It wasn't bad enough long enough during the calendar year. So for example, the red tide bloom this week. Yeah.
The presentation you give though says green, it's good.
Yeah.
Not great, but it's good.
Well, not. But if you go back, it actually used to be blue. So it did degrade, but that hurricane impact was in the last 3 months of the year, not earlier. So the 3 months, and we did show that Blackburn Bay had the bacteria levels that were higher than the only place that exceeded the bacteria levels was Blackburn Bay. It's true, but like the water quality for 9 months of that year, because that photo that we showed you, that was also Blackburn Bay in August, in a wet season. In August, in 2022, Blackburn Bay was in really nice shape. In October, it was not.
Periods in 2022, but the issues that we have with a map that past shoreline, we sit there and rot all summer, and obviously red tide, the fish kill that we had.
Yeah.
Those were not followed either, or at least not immediately followed. And they were 6 months later, 8 months later. So I have a hard time seeing your scorecard, you're relating your green to, okay, it's good, it's getting better. But it's terrible.
Well, it's related to what it was like 2006, 2012. So that wasn't pristine back then, but I go diving on a regular basis. Two weeks ago, we were diving in Blackburn Bay and Little Sarasota Bay, and there's Lingia out there. It's that gumbo, people call it snodgrass, mermaid's hair, something like that. There's a lot more of that in the upper part of the bay. That is not something that's unique to Blackburn Bay or Little Sarasota Bay. And actually your numbers, and we just crunched them like 2 days ago, your numbers of the amount of macroalgae in Blackburn Bay as of April were lower than any other part of the bay. So, I mean, I know that it differs spatially from one place to another, but you know, when we showed that picture, the aerial photography in October, it looked horrible. It smelled horrible. We had the very high levels of bacteria. In August, it was beautiful. And I think you had more pretty days, if you would, in the early part before the hurricane came through. But yeah, you were so close to the input from Don and Roberts Bay. And I think that was one of the biggest problems is we went out right after Ian came through on an incoming tide. Don and Roberts Bay's flows get shoved up north into Blackburn Bay. And some of the worst water quality we had in Blackburn Bay was in the southern part, close to Venice, because you were also close to Shackett Creek and all that influence as well. So
my concern
is
that when you show a chart like that, you're showing some improvement and you're showing it to be, you know, 4 colors that you got. Blue being best, green being next best, yellow then red. And when you're saying that that area is green, you're presenting to the whole community that it's good, but it isn't.
I'm not making the numbers up.
You're not living there.
But I'm pulling water samples there. And I'm diving to the bottom of that bay.
The whole chart was about quality of life.
Yeah.
Not about your samples. It's about quality of life. You made a very big point of differentiating between data and quality of life.
Well, the report card is nitrogen, chlorophyll, algae, and seagrass. And I can give you the numbers on all of them.
Okay.
I do think there are places get lost, and there are subtleties that get lost. But we do bring up the fact that like the only aerial photos I've showed you were Little Sarasota Bay and Blackburn Bay. And I also showed you that we did have very high levels of bacteria. So the score turned out to be green, but it used to be blue. So it did show degradation. Yes, sir.
You mentioned the
seagrass. I apologize. I didn't know how much time you had.
You're good. Go right ahead.
Yeah, sorry.
You mentioned the seagrasses and the loss of seagrasses was because of nitrogen. You didn't mention suspended sediment blocking sunlight for the grasses.
Yeah, it's mostly the thing that mostly affects our water clarity is how green it is. Florida's pretty flat, so we don't have an awful lot of sediment that actually clouds the water like in like Mobile Bay or Chesapeake Bay. We're flat. We don't erode our watershed so much. So what mostly affects us is how green the water is, and how green the water is a function of the nutrient load and also the residence time. So Little Sarasota Bay, 2 weeks after Ian came through, had 100 micrograms per liter chlorophyll. That was by far the highest we'd seen at any time. And that was because it was green. If that was sand, it would have settled out really quickly.
The follow-up question?
Yeah, sure.
The Grand Canal system is 9 miles long. It's pretty green, but it's also filled with sediment. Is there any way you could geoengineer that system so we could grow seagrasses in the canal?
One of the best things about that canal, and I've been out through that thing, is like it's not excessively deep. So I think your depths in there, they're less than 10 feet, right? Aren't they?
4 to 6 feet.
4 to 6 feet. And that is good because honestly, that may be a hassle for your boat. That means it's not so deep that you can't get oxygen in the bottom. And that does mean you could get seagrass to grow there. There might be, one of the things that we've been working with some of you guys with is to get more of those artificial reefs, or we prefer vertical oyster gardens because, you know, the state agencies don't like plastic, even though they're permitting plastic seawalls everywhere. But they don't like plastic artificial reefs, so whatever. So anyway, we're promoting oyster gardens. If you want to like, we work with the oyster boys to actually, you know, we work with restaurants to collect their oyster shell, and we have volunteers who string them up and you hang them underneath your docks and allows oysters and more filter feeding. But definitely one of the big things is, please don't make that canal that much deeper, because if you want to see bad water quality, go to a 12-foot deep canal, and that's where you have a real problem. Listen.
The 1974 study by New College said that canal is eventually going to just fill up with all the sediment that the stormwater utility keeps sending in off of the roads. So it's not going to get deeper.
I think there's less stuff in, well, you know, there is, the water's now, the sea level is now like 6 inches higher, but I think there's less sand and runoff than people think there is, you know, and yeah, they can be localized and everything like that, but if it's too deep, then you get an oxygen and then you get that muck buildup. If it's shallow, and I've been into, you know, miles in that canal and it's still a sandy bottom, that's really pretty cool.
Right, that's not fun.
There's one question back here. Oh, sorry.
Is there a way to geoengineer and take all that sediment out of the Grand Canal at one time, and then it'll stay clear for a long time? But 100 years now, it's probably still sediment that was there from 100 years ago.
You know, be careful what you ask for. If you took out too much sediment, you might make it too deep, you might have a worse problem.
We have a question back.
Yeah, the one thing I was going to ask, a little off topic, but I'm saying is around Big Pass with the last storm.
Yeah.
A lot of the sand migrated and turbidity and was brought up into South Lido with the Great Bomb. Is there a way to do a seagrass study that compared to the last one that was done? I would really lost because we couldn't control.
Yeah, seagrasses are mapped every 2 years by the district. They do it usually in the November to February timeframe. So the last map was 2022. The next one will be 2024, which means this coming November to the February, a couple of months later, is going to be when they shoot aerial photography again. So it'll be followed up in just about 6 months. Jim?
Yeah, you were talking before about the fish habitat that's in the little Sarasota Bay now. It used to be little fish that's long time ago.
Yeah.
I believe the habitat before was up the creeks and the canals, whatever have you. The Dean Creek, Ellenborough Bayou, you know, those.
Yeah.
Wouldn't it make sense to try to reestablish those areas as habitat for the juvenile?
Yeah, I think it does. I mean, the greatest percentage of the shoreline in mangroves is in Little Sarasota Bay, and that surprises people unless you go there. And because if you go around Little Sarasota Bay, you see more mangroves than in Roberts Bay or in other areas. And so, yeah, I think you can take advantage of the fisheries habitat that's there. And I think you can do more. And I think, you know, we're not against the tidal restoration, but I think it needs to be carefully thought out how you do it. But I think there's a way forward. I really do.
Well, any other questions? Otherwise, we will go ahead. One more?
If you open up in advance, are you gonna have a problem with red tide coming in Little Sarasota Bay?
It'll be easier for red tide to get into Little Sarasota Bay. In 2018, where red tide was raging up around Big Pass, New Pass, St. Armand Circle. Remember how bad that was? Remember how there was no business and just flies everywhere feeding on the dead fish? The worst red tide levels were up around Longboat Pass with 14 million cells. Little Sarasota Bay had less for a couple of reasons. It's harder for red tide to get in. Right. And it's a lower salinity, and red tide does not do that well in low salinity. So yeah, it would be, you'd be more susceptible when you have red tide. And honestly, red tide is not going to go away. Humans we don't cause it and we make it worse. And the biggest source of nutrient loads for making red tide worse is the Foothashy River. And there's nothing on the horizon in the next couple of decades that's going to make a demonstrable dent in that. The biggest project out there is the C-43 reservoir. It's going to reduce nitrogen. It's not built. It's not even close to being built. It's not even designed. Closest it's going to get is maybe a 5-6% reduction in nitrogen levels coming out of Caloosahatchee. So the Caloosahatchee is going to continue to fuel worse red tides over the next couple of decades. So it's just not going away.
That was wonderful, and I appreciate it. I can't wait to have another opportunity to have you here. Thank you.